Hello and welcome to another video. This one's one which Emma gave me just as I was walking out of school today, but it's so sorry I couldn't do it at the time, Emma, but I felt bad having to dash off, but I had some tuition to do. Yeah, I can see what you mean about this question. It's strangely fiddly. It shouldn't be hard, but it kind of feels like it almost is. You know, you do sit there kind of organising the information carefully in your head. Part A is fine, and I know you did part A fine. It was B you wanted a hand with. I mean, even part A though, it's not mega simple, but it's reasonably simple. But it's yeah. Let's have a look at it. So we have a hyperbola, x y equals 9. Remember, that's basically like a y equals 1 over x curve. I've got it here. It's this one. Here, the y equals 1 over x curve, except it's y equals 9 over x, and that does is stretch it in the y by a factor of 9. So that's this one here. Yeah, I've drawn everything actually for part B. So we've got, you know, like I say, something like that going on, yeah. And then they say, okay, basically on the general point P, you've got some kind of a tangent, yeah, like that. And they just want you to show that this is true if it's definitely a tangent. Well, what we can do there, it's pretty kind of natural what we'd do here. We'd say, okay, well, if it's a tangent to this, then this line, when I plug it into this equation, and, you know, treat it as it indeed it is, a quadratic in x, because C are constants, we get that. And now we can use the principle that this should have just one repeated root because it's a tangent, yeah? That's the case when we're finding where a line intersects a curve. If it's only got one root, then it should be, the line should be tangent to the curve always. Okay, so what are we going to do next? We're going to, like, as we know it's only got one root, we're going to use a discriminant. And so, okay, b squared minus 4ac is equal to 0. And we get, therefore, oh yeah, can I put that in inverted commas because we've got a different meaning for c. Our c here is our b. I'm going to put it in quote marks, trying to imply to myself these aren't the same letters as these. The number of times I've made a mistake in maths by introducing like using the same letter for two different ideas. If you do that in your algebra, you know it's like it quickly goes wrong. So be careful when you do write something like that. Anyway, your b is c here. So yeah, c squared minus 4m times minus 9 equals 0. And so you get c squared plus 36m is 0, and therefore k is equal to 36. Yeah, and I think that's nice and that's fine. You know, it's not too unusual in part of the question. Okay, then they introduce a parabola. A parabola, y squared equals 32x. Well, that's like y equals root x. So it looks like that. It's just been stretched, and we can also work out from the formula book that the directrix equation will be x equals minus a. Yeah, okay, all well and good. Now that crosses the x-axis at point Q, which, well, straight away, if it's crossing the x-axis and x equals minus a, well, as a is equal to 8 for this particular parabola, we know it's going to go through x equals minus 8. That's that on my diagram there. I don't know if I can just move my diagram over. Because now, and this is the next point, the line L1, which is this line up here, the tangent, in other words, you were just talking about, passes through Q. So I've drawn my tangent there, cunningly passing through Q. I'm trying to imply that this is, you know, this is what's going on. I'm trying to give you a visual, like, you know, kind of handle on what's going on. You don't need it to get the question right, but it's nice if you know what, if you draw quick graphs of what's going on, it can kind of imply that your answer is correct. Okay, so the line L1 passes through Q, and the line L2 is normal to H at the point P. So in other words, this is L2. Yeah, on my diagram, this is L2, sorry. Let's get rid of that 1. And this line is L1. Yeah, that's L1, that's L2. Okay, it wants the gradient of L2. Now, my thinking is this. We will firstly think about the fact that we've got L1. Well, we already have a condition on L1, and that's this condition here. And L1, remember, is y equals mx plus c. We also know, though, it's just told us that L1 passes through Q. So L1 passes through. My handwriting is getting worse and worse. I'm tired, sorry. So Q's coordinates, as I just pointed out, that's minus 8, 0, because it lies on the directrix. It's where the directrix crosses the x-axis, so it's minus 8, 0. So I'm going to plug that into L1. That seems sensible enough. So 0 equals minus 8m plus c. So I get this interesting fact that 8m equals c. Now remember that the gradient of the tangent, the gradient of L1, is the gradient of the tangent. The gradient of L2 is the gradient of the normal. L2 is the normal gradient. Okay, so if I can find the gradient of L1, which is m, then I can easily deduce the gradient of L2. Now, how am I going to find the gradient of this m here? Well, I'm going to use this in the in the result that I just proved. So I'm going to put 8m all squared plus 36m equals 0. And then I'm going to realise that's 64m squared plus 36m equals 0. I'm going to factorise it. I can take out a lot of factors there actually. I can take out a factor of 9m, and then I think 9m, what am I talking about? I can take out a factor of 4m, and then I can make this 16m plus 9 equals 0. Yeah, and hence it would appear that either m equals 0, and I'll talk about why that's nonsense in a second, or m is minus 9 over 16. Yeah, now m can't equal 0 because the gradient of L1, yeah, cannot get to 0. It's basically because the hyperbola isn't defined for that particular value of y. When y is 0, you can't have 0 equal to 9. In other words, implicit in this equation is the fact that y doesn't equal 0. And if y can't equal 0, then we certainly can't have from this m equals 0, in which case c equals 0, in which case y equals 0. So we can certainly exclude that one. And so the gradient of the tangent must be minus 9/16. Yeah. Now, if that's the gradient of the tangent, then what's the gradient of the normal? What am I looking for? That gradient must be 16 over 9. And so I believe the exact value for the answer they're looking for, the exact gradient of L2, is 16 over 9. I'd be interested in seeing the rest of this question. I'm presuming that there was another part to it, just because it doesn't feel like I've done anything really much with the parabola, short of like establish where Q is. I don't know, is that part of a question, or does it ask you for some other stuff afterwards? I'd be interested to hear. If you can let me know in the comments or whatever. Is that it? And I don't mean that as in it's simple, because it is weirdly confusing actually in this bit. I know what you mean, it is weirdly confusing. But then when you look at it, you think, it's not too bad. But yeah, it's kind of strange. I believe that's all right. I hope that's good for this one. Keep up the hard work and let me know in the comments if it's still confusing, or if I've got the answer wrong indeed. I don't think so. I hope not. It looked all right in judgment when I drew it. Anyway, I'll stop waffling. Well done, thanks for listening, and bye bye.